The roller coaster of the adjacent diagram, a car taken as a particle of mass 250 kilograms, starts from a point A of height HA above ground. In order to continue its motion without falling down, the car should reach point B on the track with a speed whose minimum value equals the square root of g times r, where g is the gravitational acceleration and r is the radius of the circular part of the roller coaster track. R equals 19.6 meters. The altitude of B above ground is 40 meters. Take the ground as a reference level for gravitational potential energy. Let's study the motion of the car without friction. Number 1. Calculate the minimum value of the speed at point B. The minimum value equals the square root of g times r. Plugging in the numbers gives the value of this speed. It is 14 meters per second. Let's move to part 2. Calculate the mechanical energy of the system car Earth when the car is at point B if the speed at point B is 14 meters per second. The mechanical energy of the system equals the kinetic energy plus the gravitational potential energy. The kinetic energy is 1/2 mvb squared, and the gravitational potential energy is mghb. hb is the altitude relative to the reference level. It is equal to 40 meters. Plugging in the numbers gives the value of the mechanical energy of the system at point B. This value equals 12.5 times 10 to the power 4 joules.
Number 3. Deduce the value of the height at point A if the car starts from rest at point A. Since the work done by the non-conservative forces is 0 between A and B, then the mechanical energy is conserved. So ME at A equals ME at B. The mechanical energy at A equals the kinetic energy at A plus the gravitational potential energy at A. So MEA equals 1/2 mVA squared plus mgHA. The mechanical energy at B equals 124500 proved in the previous slide. Plugging in the number gives the value of the height at point A, which is equal to 49.8 meters.
Let's move to part 4. Deduce the work done by the weight of the car as it moves from A to B. The work done by the weight of an object equals m times g times h initial minus h final. The initial height of the car is HA and the final height is HB. Then, plugging in the numbers gives the value of the work done by the weight, which is equal to 2.45 times 10 to the power 4 joules.
Focus, please. This is important.
Number 5. Determine the altitude and the speed of the car when its kinetic energy becomes 2 times the gravitational potential energy. At a certain point, the height is h and the speed is v, so that at this point, the kinetic energy equals 2 times the gravitational potential energy. We know that the mechanical energy equals the kinetic energy plus the gravitational potential energy. Replace Ke by 2 GPe, then the mechanical energy equals 3 GPe, but GPe equals mg times the altitude h, so me equals 3 mgh. The mechanical energy is conserved, so it remains 124500. Now, plugging in the numbers gives the value of h, which is equal to 16.6 meters.
Now, let's calculate the speed of the car when its altitude is 16.6 meters. Ke equals 2 GPe. Replace Ke by 1/2 mv squared and GPe by mgh. The m's cancel out. Then, v equals the square root of 4 times g times h. Plugging in the numbers gives the value of the speed at this altitude. The speed is 25.8 meters per second.
Part B. In this part, the friction forces are no more neglected, and the work done by the friction forces acting on the car between A and B equals minus 10,000 joules. In order for the car to reach point B with a speed of 14 meters per second, it should start from A with a speed VA. Determine the value of VA. The variation in the mechanical energy between A and B equals the sum of the work done by the non-conservative forces between A and B. The variation in the mechanical energy equals ME at B minus ME at A. And the friction forces are the only non-conservative forces that do work between A and B. So the sum of the work done by the non-conservative forces equals the work done by the friction. ME at B equals 124500 proved before. ME at A equals the kinetic energy at A plus the gravitational potential energy at A, and the work done by the friction equals minus 10,000 joules. Plugging in the numbers give the value of VA, which is equal to 8.94 meters per second.